In this final video, I want to say something about our plans for the next few months, for the rest of 2020. As you've seen, we have the Marlowe Playground, and that gives us a development environment for small Marlowe contracts. And also we have the Blockly part of that for doing visual development. We'll be looking at enhancing the Blockly in some ways. For those of you who have seen Marlowe previously, what we've done is tighten up the Blockly representation, but we're also looking to make that extensible in some ways. And we'll have some further news about that in a couple of months' time, I think. We'll also look to, because inside the playground we use the same editor as in Visual Studio Code, we'll aim to be moving a lot of the functionality so that it can also be supported in VS Code through the Language Server Protocol and hopefully in other IDE development environments. So supporting larger scale development of Marlowe. And as you can see from the diagram, we link that to the cloud. We have cloud-based analysis, and we'll expect to be able to carry on delivering that for other IDEs. What remains to be done is joining up the playground is a playground. It's a simulation and analysis environment. What we need to do, we have the implementation of Marlowe on a high fidelity simulation of the blockchain, what we call the mock chain. What we need to do is roll Marlowe out onto the main Cardano blockchain and build links with users' wallets. So these are the dotted lines are work still to be done. We have the language environment as it is, but we need to make all those links with the main blockchain. And that will be done primarily on top of the integration of Plutus into the Cardano blockchain. Because Marlowe is a Plutus smart contract implemented as that, we can use all the Plutus infrastructure, enhancing it in some ways to specialize it to Marlowe. But we can use that. We'll depend on that. So that's our long-term plan for the rest of the year. Specific things we'll be looking at is allowing people to exchange roles in contracts, so tokenizing roles and securitizing roles. So potentially you could split a role into, share it between a number of people. And all this is implemented on top of the Plutus multi-currency. We need to think about how we'll integrate running of Marlowe contracts with users' wallets. We might use a view very much as we see in the Marlowe Playground. And we'll be able to do some work because, as we do in the playground, we can predict what inputs and so on are expected. We can automatically generate APIs or indeed automate operations. So that's something we'll be looking at. We're continually working with the IOHK web team, getting really helpful advice about the overall user experience of the playground. Those of you who saw the playground a few months ago will see we've done a massive redesign. We're happy with that, but we'll be making some smaller changes to that continually. We need to worry a bit about scaling technology. We've done some substantial work on improving SMT solving in the analysis, but we need to make sure that things we run in the browser can run sufficiently efficiently. We're working with people from the Actors Foundation. We're getting valuable feedback and examples, and this will factor, what we get from there will factor back into the playground, but also I think into the language itself. We may be adding one or two constructs that are particularly helpful for Actors contract formulation. And finally, we are thinking about developer experience. We've got the playground and an IDE, but we can see that both of those will be valuable. You know, the playground for end users, whereas the IDE for library developers, say. So we need to think about, we don't see that there is a single set of Marlowe users. So just to conclude, what we have in a nutshell is we have an embedded domain-specific language in Haskell with a small step semantics, which we use to power the implementation on blockchain, because Plutus is Haskell. It runs on the extended UTXO blockchain, and we're also able to use the same semantics to prove properties of the Marlowe system in Isabelle. We're also able to analyze that semantics in the Z3 SMT solver to give us properties of particular contracts. And all of this is made available at the moment through the Marlowe Playground for developing, analyzing, and simulating Marlowe programs. And let me conclude by just putting up the URL of the Marlowe Playground, and that's where you can find all the facilities I've talked about, and where you can start playing with Marlowe. Thanks very much for listening to these videos, and I hope you enjoy the experience of working with Marlowe.